Hello, my name is Darren Thomas and I'm the Director of Educational Research Techniques. This is Easier, Practical Applications of Machine Learning Algorithms in R, and we are now in Unit 6, Lesson 2, and we're doing our data preparation for support vector machines with numeric prediction. So let's go ahead and go over to RStudio. So we're in RStudio, and you can see here in line 1 the 3 packages that we're going to be using throughout this particular unit. So the E1071 package is where we're going to get our support vector machine excuse me, numeric prediction algorithm from. In the last unit we used the kernel package. Different packages have access to often similar algorithms, and so in this particular instance we're just going to use E1071 this time. The other package we're going to be using is Correlational Plot. That's just for visualization purposes, and then of course the ECDAT package right there is where we get our data from. And so our data set that we're going to use, I'm going to run this first line, is Mirage. So before we look at that, let's figure out what is Mirage about here. Alright, so let me go ahead and zoom in. The information is available to my right. And so you can see here labor supply data. So we have 753 observations, and these are the different variables that we have. So it deals with, the wife's age, the husband's age, whether or not they have children between a certain range, earnings for husband, earnings for wife, hours they worked, etc., educational. So this is just basic demographic data about families, essentially. And we're going to be trying to predict here. Our goal is to predict, we'll learn more about this in the next lesson, is income. That's going to be our goal here, but I'm getting ahead of myself. So if I'm here in line 3 now, if I press Control Enter after using the str function, you can see that we get some information about all of our variables. So you can see that most of the variables are numeric or integer data. That's very useful for our purposes, but we do have 2 factor variables there. Now what we're going to do in line 5, I hope this is not too complicated, is that we're going to rearrange the order that the variables or the features appear inside the actual data frame. And so what's going to happen is that we're going to put the factor variables next to each other just for convenience sake. This is not something you have to do, but this is not the only way to do it, but we're just going to do it for these purposes, like so. So we're going to call this new data set Mirage scale. And if you look at line 5, all I'm doing here is I'm just rearranging the order that the variables appear in. So the last variable, or I'm sorry, the second to last variable, city, is going to be right here, is going to become the first variable, and then the first variable, work, is going to become the second variable in this order right here. And that way I put all my factor variables together. Again, this is not the only way to deal with this, but this is how I chose to deal with it. So I make my new object called mirage.scale. Alright, and so now what we're going to do now is we're going to scale the data in line 6. Remember that when you're dealing with support vector machines, you have to scale the data because of its sensitivity to scale. If the numbers are very big for one feature and very small for the other, you'll get weird stuff happening mathematically. And so in order to do this, we have to exclude our factor variables because they're not really numeric in that sort of a way. And some people argue that maybe you should just get rid of the factor variables altogether, but we're going to leave them there for our purposes. So if you look here in line 6, right around this area right here, you can see that I exclude the first and second variable. Now, let me just show you the first and second variable so I don't lose you here. You can see now that variable 1 and 2 are factor variables because remember, I moved city to the top. That's why it's up there. And so I'm excluding variables 1 and 2 in my code in line 6 because I do not want those to be scaled. I want those to stay the way they are. And so that's why they're being excluded by using that negative number inside the brackets. Alright, so I'm going to go ahead and run this. And also notice how I'm scaling also. I'm using the scale function and I'm saving all this as a data frame. Now in line 7 and 8, I add in my city and my work variable again. Alright, so now I'm good to go. And so if I just show you this again, let me show you what Mirage scale looks like, just so you know. Now you can see if you look closely here at the bottom that we have our 2 factor variables at the very bottom of the data set now. Remember, they used to be at the top like this, but they were excluded. And also notice a change in the number values. So look at hours worked. It was 1610, 1656. Now hours worked is more like 0.99, 1.05. It's been scaled. Everything's been scaled except for the factor variables. So now in line 9, all we're going to simply do now is we're going to create our correlational plot to see, the relationship between the variables. And so I press Control Enter, and you can see. Let me go ahead and make this a little bit bigger for you. Here is our correlation plot. And so when the numbers are a dark blue or a dark red, it may be signs of a correlation. A correlation that's very strong. So you can see here between age of the wife and age of the husband, 0.89. That's reasonable because men and women tend to marry someone about the same age as them. So that's not too much of a surprise. So if you're really serious about this, we might remove one of these because they're basically measuring the same thing. The rest of them don't seem to be too bad, although we do have a high correlation between income and wages, hours worked. So again, that makes sense. The more hours you work, the more income you make. We might choose to exclude one of those. But the rest of these, if you can see how they're kind of faint, it means that they're probably not too strong of a correlation. All right, so that's not bad. Let's go ahead and zoom out. All right, so we're just about done here. Now in line 11, we set our seed, and now we're going to set up our sample. Now in the past, we used to create data partition function from caret. This time we're doing it slightly different, just to expose you to different ways of how you can wrestle with your data. So what's happening now is that we're going to take a sample, and we're going to go from numbers 1 to 2, 1 to 2, 1 to 2. And the number of rows is going to be mirage. And it's going to be sampling with replacement. And 70% of the data is going to be tagged as a 1. And 30% of the data is going to be tagged as a 2. So we're going to go ahead and run this in line 12. So let me show you what it looks like when you do that. You can see here just a bunch of 1s and 2s, 1s and 2s. All right. If you made a table, you'll probably get... You can see right there we got 511. I can do a prop dot table, and you can really get an idea of what's going on here. And so you can see 67 of the rows in this IND are labeled as 1s, and 32% are labeled as 2s. That's close to what we wanted right here. Now here's what we're going to do. We're going to map the ND1 to the mirage.scale data set that we made. And so wherever we put a 1 at, we're going to put that in the training set. So we're going to line all the data. We're going to line the, it's like we're adding another column. How do I make this clear? What we're trying to do is that we're going to map the ND data set. Let me draw you a picture. I think that'll be better. We've done this in the past, but I want to make sure this is clear. So what we're doing is this. We have our ND. And it has all those 1s, and sometimes 2s and everything. And this is what's happening. I have my mirage scale data set. And so I have, a row here, row, all the way to, 730 or whatever. And what's going to happen now is that we're going to map the IND almost like a new column. So you'll have a 1 right here, maybe a 1 here, then a 2 here, then a 1, whatever. And what's happening in the code right here in line 13 is that wherever the IND, wherever there's a 1, so here's a 1, take this and put it in the train set. Take this right here, put it in the train set. Leave him here because he has a 2 there. Take him because he's like that. And so this is what's happening. All the rows that are mapped as an ND1 are going to be put in the train set, and all the rows that are mapped as an ND equal 2 in line 14 are going to be put in the test set. So what happens is that you get this 67% of the data is going to be in the training set, and this 32% is going to be in the test set, like that. That's what's happening. I hope that makes sense. And so after doing that, we're essentially done with preparing our data. So in the next video, we're going to start working with it to start making, setting up a model and designing things so that we can try to predict income. So my name is Darren Thomas. I am the Director of Educational Research Techniques. This is easier, practical application of machine learning algorithms in R. Take care.